Good morning, ladies and gentlemen. We're going to look at some factoring polynomials. This is intermediate part B. This will be lesson number number 6. We're just going to look at a few examples, go over some basic little techniques that I like to use. And then if you have any questions, just let me know in the teacher message. So here we go. So for what we're doing, we're working with a quadratic equation in standard form, ax squared plus bx plus c. And when we factor, we're going to look at two different situations. The first situation is when a equals 1. So we'll just have x squared plus bx plus c. And then the second situation is where a is not equal to 1. So that's where we'll have some number other than 1 as a plus bx, and that's x squared plus c. So a situation over here would be something like x squared plus 4x minus let's say 12. I don't know if that factors or not. I'm just making something up real quick so we can move on. Over here, ax squared plus bx plus c, that'll be something like 6x squared plus 5x minus 10. So something like that. So those are the kind of things we're factoring. And the ones that we're going to look at all factor. Now, if they don't follow some of these rules that we look at, then you have to check to make sure whether or not it factors. That'll be something for a different lesson, maybe something in the help sections. So here we go. Here's our first example. We're going to factor x squared minus 13x plus 40. So when we factored this, here's what we want to get. We want to get two factors with x and some number, and then either plus or minus signs in the middle. And I'm going to show you exactly a quick technique that helps you just fill these things in as long as you know how to factor a basic number. So for this example, we got x squared minus 13x plus 40. So here's where you look. You look right here. And we need factors of 40 that do this. Add to equal this number. So factors of 40 that add to equal 13. Now don't worry about this sign yet. That sign will come in the next step. So I factor 40. So what are some factors of 40? Well, some factors of 40 are 2 times 20. 40 times 1, and 8 times 5. And if we look at 8 times 5, that equals 40, and then 8 plus 5 equals 13. So these are the factors I want to use. So this is the one that I want to use, 8 times 5. So now I build my factors. Now this is how I build my factors. So I'm going to set my parentheses. And x goes in each one. And then I put one of each of these factors in each one. So an 8 in one, a 5 in the other. It doesn't matter which is which. We're going to put the signs in correctly, and then that's going to make everything work out. So now how do we get the signs? So here's my rule for the signs. I look at this first. If it's positive, the signs in the factors are the same. If it's a minus, they are different signs. Don't get confused with subtraction and addition yet. So now, I have a plus sign, so they're the same. So now which sign should I put? That's where this one comes in. So I'm going to look at that and put that sign in both factors. And so that is how it is factored. X minus 8 times x minus 5. And please don't be afraid to check your work and make sure you're right. So we're going to check. How would I check? I would FOIL. X times x is x squared. X times 5, negative 5x. Negative 8 times x, negative 8x. Negative 8 times negative 5, positive 40. So when I simplify that, I have to get this back. And so I do. I get x squared minus 13x plus 40. So these are my two factors. And I'm going to clear some of this stuff out here. So these are my two factors, and I'm going to box those off in red. And right there's my final answer. So I'm going to go through this one more time with a different example. So again, I'm trying to build two factors, x and a number, x and a number. And we got a plus or minus sign in the middle. I look at the last number, 63. This time I need factors of 63 that do this. Subtract to equal 2. Well, what are some factors of 63? First two that come to mind is 7 and 9. 7 times 9 is 63. 9 minus 7 is 2. So those are the two factors that I need to use. So I build my factors. So I have an x, 7 in one, 9 in the other. Remember, those two don't matter as long as the signs are correct. Now, in the last slide, I told you that this was where I look first to determine the signs. Remember, if it's plus, they're the same signs. This is a negative, so that means I need different signs in my factors. So that means one has to be plus, the other has to be minus. Now, how do I determine that? I look right here. That sign goes in front of the larger of the two factors. Since 9 is bigger than 7, I'm going to put a plus sign right there and a minus sign right there. And remember, don't be afraid to check your work here. So x times x is x squared. X times 9 plus 9x. Negative 7 times x, negative 7x. And then negative 7 times positive 9 is negative 63. Those two factors do equal positive 2x, so I have the right factors. So again, let me get rid of some of this stuff here. here are my factors, and I'm going to box those off in red. That's the factors that I'm looking for. All right, so here's the next example. Now this is the other case. This is where the leading coefficient is not 1. So this time when I build the factors, I'm going to have a number times x plus or minus a number, and then a number times x plus or minus a number. And I use a little different technique here to get my factors. I use a box. Some people like to guess and check. I like to use this box. And here's how you use the box. So these two things, or this goes in the first box, always in that box. This, without the sign, I should have just circled the 4. Let me go back and do that. This goes here. Now here is where I do my guess and check. So what do I do next? Well, now I take A and C. Remember, this is ax squared plus bx plus c. So I multiply A and C. So in this case, 3 times 4. And now I factored that number. What are some factors of 12? And I go back to the problem that do this. Subtract to be 11. Well, the only factors of 12 that will subtract to be 11 are 12 and 1. So then I go back to my box and I put those factors in and add the variable. Now here's where I actually create my factors. So what I do is I look left and right, and then I look up and down. So if I look left and right first, this way, I find the GCF, the greatest common factor of the terms. So what do these two terms have in common? Well, they have a 3, because both numbers are divisible by 3. And since both numbers have an x, they have an x in common. So now look at the second row. What do these two have in common? Well, no numbers in common, so every number has a GCF of 1, every pair of numbers, if there's nothing else in common. So that's one set of factors. Then I'm going to look up and down. So what do these two numbers have in common? They don't have a number in common. 1 and 3 are both prime, so the GCF of those is 1. But they do have an x in common, so there's an x. And then I look at these two. What do they have in common? Both 12 and 4 are divisible by 4. So there's my factors. And so I build my factors. And again, I don't put the signs in until I do a little checking. Now again, I have to look at this last sign first. Since it's negative, that means the signs have to be different. And I have to kind of guess on this rule because it doesn't work all the time, but I still like to start off putting that one in front of the larger of the signs. Since 4 is bigger than 3 or 1, I'll start off putting the plus sign there, the minus sign there. And then this is all you need to check. you need to check the outer. What's x times -1? That's -1x. And then you need to check the inner. Now, if that equals positive 11x, which it does, then my factors are right. And I have factored this trinomial. And so that factors into those two binomials. Okay, one more example of this. So again, I'm trying to build my factors, so I'm going to use a box for this. I like my box. Some teachers don't like my box. I like it. If you don't like it, I can show you another method. So remember, this goes in the first box. This goes in that box. Second step is to multiply the 5 and the 16. 5 times 16 equals 80. So now I need factors of 80 that do this. Subtract to equal 38. So what factors of 80 subtract to equal 38? That's 40 and 2. So I must take a 40x in one box and a 2x in the other box. And now I find GCFs. So what is the GCF this way, left and right, for each row? So I look at 5x and 40x. They both are divisible by 5, and they both have an x. And then I look at 2x and 16. They're both divisible by 2. So then I look up and down. So what do these two have in common? The numbers have nothing in common, but they both have an x. So I have an x. Look here and here. What does 40 and 16 have in common? They both are divisible by 8. So there's my factors. I have x and 8. I have 5x and 2. Again, I look here first. Subtraction, so the signs are different. I'm going to start off with this one in front of the biggest factor, which happens to be 8. So I'm going to put plus there, minus there. And then I have to check. Please always check these. So outer, that's -2x, inner, plus 40x, that's going to equal positive 38x. If it wasn't the right number, if it was a different sign, then all you would have to do is switch those two signs. But always check these. So I have my factors right, and so my final factors x plus 8 times 5x minus 2. Okay. Now we're going to look at some special cases. So this is a special thing, and really and truthfully, all you need to do is just learn this little quick technique I'm about to show you, and you can factor these very quickly. These are actually easier to factor than the last ones we were looking at. So here is our first example. So let me go back and explain this again. So in order to be a difference of squares, both of these terms, A and B, that's the numbers in front, have to be perfect squares. So now what do I mean by perfect squares? I mean numbers like 4, 16, 9, 25, 49, 81, 100. Whole list of perfect squares. And to factor, you're going to find the square root of each term and build the factors always like this, plus 1 minus the other. So now here's an example. I think the example kind of explains it better than the explanation. So first, check, make sure these are perfect squares. X squared is a perfect square, so is 36. So I'm going to find the square root of both things. Square root of x squared is x. Square root of 36 is 6. And so just write the factors. X minus 6, x plus 6. And again, if we check, this will be the last time I check on these because I know these work. X times x, x squared, x times 6 plus 6x, negative 6 times x, negative 6x, negative 6 times positive 6, negative 36. What happens in all of these every time is those two things cancel out. So that just leaves us with x squared minus 36. So those are your factors. X minus 6, x plus 6. Okay. Another quick example. Square root of x squared is x. Square root of 81 is 9. So build your factors. X minus 9, x plus 9. Now we'll look at this one. 3 is not a perfect square, so something is wrong here. So when that happens, look to factor a GCF first, greatest common factor. So what do 3 and 12 have in common? They're both divisible by 3. So if I take a 3 out of the binomial, I'm left with x squared minus 4. Now that looks better because x squared is a perfect square and so is 4. So again, find your factors. Square root of x squared is x. Square root of 4 is 2. And so here are your factors. I've got 3 times x minus 2, x plus 2. And here's another case. This time I've got a number in front. 100 is a perfect square, so is 121. So I find the square root of 100, x squared, which is 10x, and the square root of 121, which is 11. Write the factors. 10x minus 11, 10x plus 11. And if you don't remember square roots, just remember that what number times itself gives me this number. 10 times 10 is 100. 11 times 11 is 121. So I hope this helps you with the lesson. If not, please send me a teacher message and we'll set up a help session